Imagine this. The year is somewhere in the early 1200s. The sun blazes mercilessly over the Anatolian plains. The earth is cracked and thirsty, the air heavy with heat. Villages in the distance struggle with drought. Their fields have withered into dusty wastelands. And yet, there is one village where life seems untouched by the burning summer. The crops are green, the orchards heavy with fruit, and the streams run cool and clear through the streets. There is no electricity here, no pumps, no modern pipes. So how is this possible? The secret lies beneath the surface, in a silent, almost invisible network of channels and pathways. This is the Kill System, a medieval marvel of engineering that could draw life from the mountains and deliver it to the heart of a settlement, using nothing but gravity, ingenuity, and the laws of nature. For centuries, this system was the lifeline of communities across the Middle East, Anatolia, and parts of Europe. It was as much a product of necessity as it was of genius, and designed to function without fuel, to operate without supervision, and to last for decades, even centuries. And here's the most fascinating part. In some remote corners of the world, it's still being used today. 1. What is the Kill System? The Kill System, pronounced kul in Turkish, was an ancient and medieval method of water transportation and distribution, used to deliver fresh water over long distances without the aid of modern pumping technology. Its name, Kill, meaning hair in Turkish, is thought to refer to the thin, hair-like channels through which water would travel. Much like capillaries in the human body, these channels acted as the lifeblood of medieval settlements, carrying precious water to where it was needed most. Fundamentally, the Kill System was a gravity-fed water conveyance network. Water was collected from a high-altitude source, such as a mountain spring, a river, or a melting snowcap, and then guided along a carefully calculated path that maintained a gentle, consistent slope. Too steep a slope and the water would rush too quickly, eroding the channels. Too flat and it would stagnate or fail to reach its destination. Skilled builders, often local craftsmen, masons, or specialist water engineers, had to strike the perfect balance. Construction materials varied depending on location and available resources. In some regions, channels were carved directly into the bedrock or lined with stone slabs to prevent leakage. In others, baked clay pipes were laid underground to protect the water from contamination and evaporation, a critical consideration in arid climates. In particularly advanced examples, the system incorporated settling basins, where sediment could drop out before the water continued its journey, ensuring a cleaner supply. The genius of the Kill System lay in its simplicity. Once constructed, it required little to no external energy to operate. Maintenance involved clearing debris, repairing broken channel sections, and occasionally redirecting flow if a source ran dry. Yet despite its simplicity, the system's efficiency rivaled that of many later industrial-era solutions. What made the Kill System remarkable was not just its technical design, but its adaptability. It could be scaled for a small rural hamlet or expanded to serve a bustling medieval city. It could feed farmland, fill public fountains, supply baths and hammams, and even provide water for defensive moats in fortified towns. The design principles remained the same, only the scope and reach changed according to the needs of the community. For medieval people, this was more than infrastructure, it was survival. In an age when water scarcity could mean the collapse of an entire settlement, the Kill System was a safeguard against famine, disease, and decline. The ability to control and channel water meant the ability to sustain life itself. It is no exaggeration to say that for many communities, the Kill System was the single most important piece of public works they possessed. How it worked in the Middle Ages. The functioning of the Kill System in the Middle Ages was an elegant balance between human skill and natural forces. At its core, it relied on three simple elements: a reliable water source, a carefully designed channel path, and gravity. Yet the execution of these elements was anything but simple. It required precise calculations, a deep understanding of local geography, and generations of inherited knowledge. The process began with identifying the water source. This was the single most important step, for the quality, reliability, and volume of the source determined the success or failure of the entire system. In the highlands of Anatolia or the Levant, springs bubbling from limestone hills were often ideal. Their water was naturally filtered through stone, cool in temperature, and flowed consistently throughout the year. In other cases, rivers or seasonal meltwater from snow-capped mountains were harnessed, though these required more complex engineering to ensure a steady supply during dry months. Once the source was chosen, the surveyors, often the unsung heroes of medieval infrastructure, would map out the intended route. Unlike modern engineers with advanced equipment, these surveyors worked with simple tools, weighted strings for leveling, wooden stakes, and sometimes water-filled tubes to measure gradients. They would walk the terrain, marking the path in small increments to ensure the slope was neither too steep nor too shallow. This slope, often between 0.1% and 0.3%, was the heart of the system's efficiency. A well-planned gradient allowed the water to move naturally, without the risk of stagnation or destructive erosion. The construction itself could take months or even years, depending on the length and complexity of the channel. In some rural versions, the kill system was little more than an open trench lined with flat stones, covered with slabs to prevent debris from falling in. In urban centers, however, the design was more sophisticated. Clay or ceramic pipes, sometimes reinforced with lime mortar, ran underground, insulated from the sun's heat. In some cases, aqueduct-like structures were built to carry the water across valleys, a visual reminder of the ingenuity of medieval engineers. But the kill system was more than just a pipeline. Along its route, engineers built small maintenance chambers and settling tanks. These acted like miniature reservoirs where water slowed down just enough for sediment to sink to the bottom. Clean water then flowed onward, leaving silt and debris behind. This innovation not only improved water quality but also extended the lifespan of the channels, reducing the need for constant repairs. In cities, distribution nodes were created at key junctions. From these nodes, the water could be diverted to different districts, fountains, public baths, and even irrigation channels for nearby farmland. Some medieval towns even had priority systems, ensuring that communal needs like drinking water and religious washing areas were supplied first before water was sent to agricultural or industrial uses. Maintenance was a constant but manageable task. Teams of workers, often funded by local guilds, charitable endowments, or municipal authorities, would inspect the system at regular intervals. They would clear blockages caused by leaves, mud, or small animals, repair cracked pipes, and reinforce eroded sections of open channels. In some communities, the responsibility for maintaining a section of the kill system was shared among several families, who took pride in keeping the lifeblood of their village flowing. Another remarkable feature of the kill system was its integration into the landscape. Instead of forcing nature to conform to human will, the system often followed the natural contours of the land, weaving around hills, dipping into valleys, and using existing rock formations as part of its structure. This not only reduced construction costs but also minimized the environmental impact, ensuring that the surrounding ecosystem was not disrupted. The genius of the system also lay in its adaptability to different climates. In dry, arid zones, channels were kept deep underground to reduce evaporation. In wetter regions, open channels allowed for easy cleaning and expansion. Where water had to cross uneven terrain, medieval engineers used wooden flumes or elevated stone troughs, balancing them carefully so the flow remained uninterrupted. In essence, the kill system was a symphony of simple principles executed with extraordinary precision. It was not a marvel of brute force, but of harmonizing with nature's own rules, a principle that made it both durable and sustainable. It could survive for centuries with minimal resources, a feat that modern water systems, dependent on constant energy inputs, often struggle to achieve. Clay in the medieval world was not merely a material. It was a language of survival, devotion, and identity. From the moment it was lifted out of a riverbank or a hillside, clay bound communities to their landscapes and to one another. It turned earth into bowls and bread ovens, pigments and pipes, tiles and talismans. It spoke in rooftops that shimmered after rain, in glazed tiles that caught candlelight in chapels, in amphorae stacked like treasure in storerooms, in modest cups whose rims memorized the mouths of whole families. Medieval people knew clay with their hands before they knew it with words. They kneaded and tempered it. They read its cracks like auguries. They trusted its slow transformations in the kiln the way they trusted the seasons. The journey from soil to sacred ornament, from mud to meaning, is the story of how matter becomes culture. At the heart of that journey lay the craftspeople, potters, tile makers, stove builders, brick and pipe makers whose work stitched together the domestic and the monumental. In villages, the potter's yard was as vital as the mill and the bakehouse. These techniques varied from the British Isles to Anatolia, from the Italian communes to the Maghreb, yet the logic was shared. Every region married its geology to its needs. Where forests were plentiful, wood-fired kilns smoldered for days. Where fuel was scarce, kilns were compact and thrifty, carefully stacked and baffled to recycle heat. Within those red mouths, alchemy unfolded, water fled, minerals sintered, ash kissed glaze into glass. The village's calendar bent around these firings. A nervous vigil, an opening day like a festival, successes celebrated, failures learned from and repurposed as grit for the next batch. Clay's domestic presence was omnipresent and intimate. In kitchens, porous jars chilled water by breath, courseware held stews that fed households and hired hands alike, and lidded pots guarded seeds through winter. Bread met clay at every step, kneading troughs, proofing bowls, the dome of the oven itself whose curve held the memory of hundreds of loaves. Heating the home was a ceramic affair too, from Iberian braziers to the great tile stoves of Central and Eastern Europe that turned fire into a slow, radiant companion. Floors were paved with fired tiles whose rhythmic patterns taught children to count. Walls were plastered with clay that moderated humidity and softened sound. Roofs wore rows of pantiles and shingles like scales, shedding weather and shining after storms. Such objects seldom traveled far, yet their forms and surface treatments, thumb impressions, combed lines, slip-painted spirals circulated as a regional grammar of taste. In the town and the monastery, clay climbed the ladder of symbolism. Glazed tiles stitched the floors of churches into repeating theologies. Saints' stories and vegetal motifs were pressed into reliefs that turned corridors and cloisters into catechisms underfoot. In some regions, tin-opacified white glazes provided a ground for colored painting, greens of copper, ambers of iron, the dark calligraphy of manganese, making plates and apothecary jars into small altarpieces of daily life. In Islamic lands and their European neighbors, cuarta and molded relief faience braided geometry and scripture across portals and mihrabs, demonstrating how clay could carry intellect and devotion at once. In Jewish and Christian communities alike, clay sealed contracts, lamp offerings, burial urns, and dedicatory tiles marking restorations, casting memory into ceramic time. Clay in the medieval world was not merely a material. It was a language of survival, devotion, and identity. From the moment it was lifted out of a riverbank or a hillside, clay bound communities to their landscapes and to one another. It turned earth into bowls and bread ovens, pigments and pipes, tiles and talismans. It spoke in rooftops that shimmered after rain, in glazed tiles that caught candlelight in chapels, in amphorae stacked like treasure in storerooms. Pigments and pipes, tiles and talismans. It spoke in rooftops that shimmered after rain, in glazed tiles that caught candlelight in chapels, in amphorae stacked like treasure in storerooms, in modest cups whose rims memorized the mouths of whole families. Medieval people knew clay with their hands before they knew it with words. They kneaded and tempered it. They read its cracks like auguries. They trusted its slow transformations in the kiln the way they trusted the seasons. At the heart of that journey lay the craftspeople, potters, tile makers, stove builders, brick and pipe makers whose work stitched together the domestic and the monumental. In villages, the potter's yard was as vital as the mill and the bakehouse. There, clay was cleaned and levigated in troughs. Straw, sand, and ground grog were folded in to steady the body, and forms were coaxed on wheels or beaten into shape with paddles against stone anvils. Where forests were plentiful, wood-fired kilns smoldered for days. Where fuel was scarce, kilns were compact and thrifty, carefully stacked and baffled to recycle heat. Within those red mouths, alchemy unfolded, water fled, minerals sintered, ash kissed glaze into glass. The village's calendar bent around these firings. A nervous vigil, an opening day like a festival, successes celebrated, failures learned from and repurposed as grit for the next batch. Religion and folklore layered clay with meanings that exceeded utility. Creation myths in the Abrahamic and many Afro-Eurasian traditions imagine humanity shaped from earth, a metaphor medieval people enacted daily. The craftsman's thumb in a pot's rim mirrored a divine thumbprint. Pilgrims purchased tiny ceramic badges and ampulla filled with holy water or all, carrying sanctity home in fired earth. Shattered, such tokens still stud riverbeds near shrines. Clay lamps lit vigil rooms and deathbeds, their sooted bellies dark testaments to prayer. In fields, clay rattles and whistles served both as toys and as apotropaic charms to frighten birds and, symbolically, misfortune. Even superstition observed material science. A cracked pot told of an ill-timed firing or a draft. Its whistling spout on a kettle predicted a change in weather.